Okay, we're going to look at the shortest path problem over here. And basically, here's two examples, right? These two arrays over here represent two examples. And this path represents the shortest path, means the lowest, the path with the lowest weight when you add up all the elements along the path. And there's a slightly, on the right-hand side, it's a slightly different array. And so the shortest path is the one that starts here at the 3 and it goes up and around as a cylinder, and we saw this in class. The question is, how do you write a function that's actually going to calculate the length of the shortest path? That's what we want to do over here. So the thing to consider is, let's take a look at this particular path. Let's look at the path on the left-hand side that starts with the 3, right, and it goes all the way through element by element. So this particular one happens to exit at the 4 over here. So the path is, the length of the path is the same as the number of columns, right? Because every element, you have one element per column on this path. So this, since there are 6 columns, the path is of length 6. So the basic thing to consider, the basic insight over here, is that if I have a path of length 6 and say it's exactly the one that we see here. So if it ends here at the 4, that path of length 6, then the initial part of that path, that was the first 5 elements of the path, the 3, the 1, the 3, the 3, and the 2, right? This initial part of the path over here, that has to be a shortest path starting at the left-hand side and exiting over here at the 5. Because if the initial part, right, if the initial 5 points on this path were not minimal, then one could find a smaller one by definition that exits at the 4, and so then the whole path would not be shortest. That's a very basic idea here. So this leads to a recursive solution, because basically what we say is that in order to find, if I knew how to find a path of length 5 that starts at the left-hand side and that has the lowest weight and goes into the 4, then, and that's a path of length 5, then I know how to find a shortest path of length 6 that does that, namely append this 4 to the whole path, right? So that's a recursion, because I can find the path of length 6 given that of lowest weight, given that I can find a path of length 5. That's the basic insight. So what we want to do is we want to write a function, and the function is going to be called cost. So we're going to write a function, and we're going to call the function cost. That's the basic idea. And so cost sub ij is going to be the weight, as it says over here. It's going to be the weight, which means the sum total of all the elements on the path, of the shortest, which is the minimal weight path, starting somewhere on the left-hand side, left-hand edge, ending in element weight sub ij. So for example, the cost, let's take a look at this position over here. So the cost of, where is this? The cost of 2, 3, of 2, 2, right, this element over here, is, given that it's on the shortest path, is going to be the 3 plus the 1, right, plus the 3. So 3 and 1 is 4, and 3 is 7. So the cost of ij, of where I and j is 2 and 2, is going to be 7. Now, how do we get this thing recursively? So basically, it's going to be the weight of this last element over here, right? The weight is 3 over here. Plus, it turns out that the 3 and the 1 are the shortest path, but I don't really know that. So when I want to compute this thing recursively, if I find myself on some position ij, I've got to find out, how did I get into that ij, right? By the parameters of the problem, I could have gotten there from one of 3 separate places, right? So I could have gotten there from this one over here, right? Or from this one over here, or from this one over here. I don't know which one it is. Right, so what I need to do is, one thing that I do know, as we saw before, is that this is a path of length 3. So the path that goes into here, into this this one over here, is going to be a path of length 2. That is the shortest path. So what I need to do is I need to go to these 3 elements. This one over here, right? I need to go to this one. I need to go to this one, and I need to go to this one, and calculate the cost of the path reaching to this cell, right, to the cell with the 1, the 9, and the 4, see the cost of the shortest path leading there, and then I'm going to pick the smallest one because that shortest path plus the 3 is going to be the shortest path going into the 3. That's the basic idea. So that means that if I want to now write this cost function recursively, so the cost of ij, and we're looking at 2, 2 for example, but the cost of ij, let's actually write it in that case. So the cost of position 2, 2 is going to be the weight of 2, 2. It's going to be the value in weight sub 2, 2, because we're talking about a path that terminates there, plus what? Plus the calling the cost function on this cell, and this cell. So where are those cells, right? So if this is 2, 2, where the 1 is, well, each one to the left is going to be in column 1. So I have to see, I want to get the minimum of these three things. I want to get the minimum of calling the cost function on, I'm going up 1. So up 1 means that the rows decrease. So it's going to be 1, 1, right? 1, 1 is this one over here, right? This one over here is 1, 1. Plus the cost of where the 9 is. Well, the 9 is to the left. So the column is going to be 1, but the row is going to be the same. So I've got to calculate the cost of row 2, column 1. And then I've got to calculate the cost of the one below it to the left. Below it to the left is where the 4 is. So that's going to be, the row increases by 1. So that's going to be row 3. And it's going to be column 1. So what I need to do is I need to calculate the cost of all possible paths going into the 3 feeder cells to where the 3 is, right? This one here, right? The one where the number cell 1, 1, cell 2, 1, and cell 3, 1. Calculate the cost function for those, pick the minimum, and add it to the weight of cell 2, 2. Now, we can generalize that and look at any particular cell. We can talk about the costs of ij, and so the cost of ij is similarly done. So if we look at the program, we're going to end up with some code that looks like this. Okay, here's the code that I posted on the website. So we have a function, here's a function cost, and in the cost function I'm passing in I and j, I is the ith row and the jth column. So we have a base case. We'll take a look at the base case in a moment, but let's forget the base case for a moment, and let's see, we're not in the base case, with some other case. So what I need to do is I'm going to calculate left, I mean the one immediately to my left. That's going to be I row, same row, it's going to be row I, column j minus 1, and then up, and then down. I'm going to calculate the cost. This is going to be the cost function plus going into the cell. So it's going to be the weight of ij plus that cost function, and so on for each one of these three. And then I'm going to have some code here that finds the minimum, and I'm going to return that minimum that I find. That's basically the code. Now, what about the base case, right? This is a recursion, right? So the reason it's a recursion is because I'm calculating, when I'm talking about being in position ij over here, that means I'm in column j, which means that my path is j elements long, right? I have a path that has j links to it, and I'm defining the cost of a path with j links in terms of calling that cost function with a path of j minus 1 links, right? The row is going to be whatever it's going to be, but the column is going to be j minus 1. So the function in terms of j, right, in terms of being in the jth row, is going to be calculated in terms of looking one before. That's the recursion. And what about the base case? So what is the base case? How does the base case work? Well, let's go back over here and take a look at the base case. So the base case is going to be where I find myself in column 0, right? Because what I'm going to do is eventually, of course, I'm going to try to call this function for elements on the right-hand side. Just like when I want to calculate, let's say, factorial of n, I do it in terms of factorial n minus 1. We're going to start here. I'm going to say, in order to calculate, let's say, the shortest path through something over here of length 6, it's going to be of length 5. And I work my way back in the recursion. So when I get to the column 4, I'm going to say, well, to calculate something of length 5, it's going to be of length 4, until I find myself over here in column 0. In column 0, these represent paths of length 1. This is a path of size of weight 3. This is a path of weight 6. Now, since that path has only one element in it, so it has nothing before it, right? So I don't make another recursive call. And so the weight of the shortest path starting on the left-hand side, let's say, for example, over here, the weight of the shortest path coming into this particular box over here, there is no initial thing before that, is just the value of the weight. That's my base case. How do I know I'm in the base case? Well, when I'm in column 0, right? When I'm in column 0 means if the value for j is equal to 0, j tells me the column, then all I do is I return the value of weight sub whatever I'm in, whatever row I'm in this case 1 and 0. So that's what happens over here, and that's what the code in fact does, right? Let's go back to the code. So I'm over here in the code, and I come in with a value. I'm in column 0 when I come in over here. So the first thing I ask, if j, right, j represents the column, so if I say if j is equal to 0, then all I do is I return the weight that's in row I, column 0. Otherwise, I'm in the middle someplace, and then I calculate the value of the total path if I'm coming in from the left, if I'm coming in from up, if I'm coming in from down. I find the minimum of those things, and then I return the value of the minimum. That's the function. That's the function called cost. Now, what does the main program look like? Right. So we have the main program is over here. And let's check this out. Let's see what the main program has to do. Okay, let's see what the main program has to do over here. So if I want to find the shortest path recursively, just like, for example, if I want to find factorial of 6, I say, well, it's 6 times factorial of 5. Here what I want to do is I want to find a shortest path of length 6. So what that means is I'm going to start on the right-hand side. I'm going to say, well, I don't know where the shortest path is. I mean, here I happen to know it comes through here. But I only know that after the calculation has been done. So the shortest path could have come through here. The shortest path could have emerged through here, right? Because it's going to start on the left-hand side, but it's going to merge someplace here on the right. So really what I need to do is I need to call my cost function on every one of these elements, right? Remember, this thing is going to be in column 5. So these elements are going to be in 0, 5, 1, 5, 2, 5, 3, 5, and 4, 5. So I'm going to call my cost function on each one of those things and store the value. Remember what the cost function is going to do. It's going to recursively call the cost function in order to find a path of length 6. It's going to call it on a shorter path, namely all the possible ways of getting in here, which is going to be from this cell here, and where else? Well, I can get in here from the one down here. We've got to make sure we take care of that case. And so on for each one of these 5 values, and then I'm going to simply pick out the minimum. And so if we look at the main program, that's essentially what the main program is going to be doing. Okay, so here's the main program. What we do is we know what rows is. The number of rows here is going to be 5. So we create an array called EX, the array EX of size 5. 1, 2, 3, 4. And what we do is in EX sub I, right, this is sub 0, 1, 2, 3, 4, we're going to call the cost function for that particular row. So here we're going to call the function cost for row 0, column 5. Here we're going to call the cost function for row 1, column 5, and so on down here until I call the cost function for 4, 5. And so to get various values, when this thing returns, it's going to deposit a value here because the cost function, of course, returns an integer, right? If we look at the cost function is returning an integer, right? It's an integer that it's returning, and it's either going to return the minimum this way, or it's going to return the minimum because of the base case, and so on. What happens here is I'm going to fill up the array EX over here, and then I'm going to write some code here, some kind of loop that's going to go through the array and find the minimum. It's going to store it in the variable called minimum, and it's going to print that value and return. That is the way this function works. Right? That's the basic idea, and you got to basically fill in the blanks and write the code, and that's the assignment.